All right, so similar polygons. We're talking about similar triangles, but we'll also have some quadrilaterals thrown in here as well. But we are comparing similar to what we just learned, which is congruent. So if two things are congruent, they have the same shape and the same size. But similar polygons have the same shape but different sizes. Okay, so polygons are similar if these two things are true. If the corresponding angles those corresponding angles are congruent, and if the corresponding sides are proportional. And a proportion is where two things have a scale factor in common. So that ratio of those corresponding sides is called the scale factor. You may have a scale factor of 2, where it's double. You may have a scale factor of 1/3, where it's 1/3 of the next thing. But that's what we're talking about with the sides. So they have the same shape, but they're going to have different sizes, as you can see by our triangles down here. If the polygons are similar, then their perimeters are also going to be proportional. In other words, if their sides are proportional, you can add up all those sides. The perimeter is going to be proportional as well. So when it comes to scale factor, order matters. So people get really confused, and even I myself get confused sometimes on how they phrase this. But it's asking, what is the scale factor of triangle ABC to DEF? So we're kind of focusing on ABC, and we're saying, compare that to DEF. What is ABC? That's kind of what we're talking about here. So that's just kind of to help you understand it. But pretty much what you do is you take whatever's first and put it in the numerator, and whatever's last and put it in the denominator. So we can just take one of the sides. Let's take AB, for example, and that's the first two letters right here. AB and DE are corresponding sides. Now those sides are proportional. They're not going to be congruent. So we have ABC is 8, or AB is 8, and DE is 12. So when we simplify that out, divide both by 4, that'll give you 2/3. So that's the scale factor of ABC to DEF. ABC is 2/3 the size of DEF. Now we can go the opposite way. We can say, what is the scale factor of DEF when compared to ABC? So we can do that exact same thing, and we can even use a different side. So let's use EF and BC. Well, BC is 10, and EF is 15. But again, whatever comes first, we're putting in the numerator, and whatever comes last, we're putting in the denominator. So we're comparing triangle DEF to ABC. So DEF is something compared to ABC. Obviously, it's bigger, so this number is going to have to be bigger than 1. And DEF is 15, or EF is 15, and BC is 10. So that will be 3/2. So you see how we flip it when we switch the order of these. The numerator and denominator switch as well. So instead of 2/3, it's going to be 3/2. And then we talk about the ratio of the perimeter of DEF to the perimeter of ABC. So the perimeter of DEF would be 12 plus 15 would be 27, plus 21 would be 38. 48. Nope, 48. Right? Yeah, there we go, 48. And then the perimeter of this other one would be 18 plus 14, which would be 18, 14, 32. There we go. Brain's not working this morning. So then we just simplify that out, and we could divide both of those by 16, and that will give us 3/2. So you notice that when we put DEF first, these are the same, right? The scale factors are the same if we're talking about the sides or if we're talking about the perimeters in similar triangles. So we also have these similarity statements, which are just like congruency statements, except they're just similar. So if congruency is this symbol because it has the equal sign, similarity is just going to be that without the equal sign because they are not the same, they are just similar. Okay, so we would have triangle ABC would be similar to triangle DEF. It's the exact same thing we've been doing before. We just do not have the equal sign underneath it. So this is a similarity statement, not a congruency statement. So we know that the angles, if we go back to number 1 up top, the corresponding angles are still congruent. So we're still going to do the same thing that we did before, where angle J is congruent to angle P, not similar. They are actually congruent, the angles. But when it comes to the sides, these sides are proportional. So here's how I would do the sides. You need to have one triangle all the way across. So I'll actually make this a red triangle and a blue triangle, and I'll erase this P, M, and N, and I'll do it in blue, just so you can keep track of the difference. So there's P, M, and N, that's blue, and then J, K, and L, that's red. So we have this similarity statement here. So JK will be proportional to PM. Okay, so JK will be proportional to PM. So I'll put JK up top, PM on the bottom. And then that is going to be equal to the same fraction of KL and MN, right? So we're going to have KL up top and then MN on the bottom, okay? And then that will be equal to our last one, which will be JL and PN. So you notice that all of the red sides are up top and all of the blue sides are on the bottom. That is how this works. They are corresponding as they go down. So in other words, JK and PM are corresponding, but they are not congruent. These values here are all going to be congruent, just like what we had up here. 8, 12, this will be 8 over 12, 10 over 15, and 14 over 21. All of those would equal out to 2/3. Same thing down here. All of these are going to equal out to 2/3. So we can do the same thing with number 2. Even though we do have two separate triangles, or even though these triangles are overlapping, we treat them as two separate ones, right? So we have our first triangle, which is XYZ, which is the biggest one right here. And then we also have our second triangle, which is RYS. So they both will use angle Y. So we have angle X, angle Y, and angle Z. And again, these are congruent. They're not similar. The actual angles themselves are congruent. X will be congruent with angle R. Y will be congruent with itself because it's used in both. And then angle Z will be congruent to angle S. So from here, our sides, we will have XY, YZ, and XZ, and all of those are proportional to their corresponding sides. So that will be RY, YS, and RS. It would pretty much be the same thing with this quadrilateral. I'm not going to use it, but just for the sake of time, but it's pretty much the same thing. And you can see it, the key down at the bottom if you want a little more help with that. So for number 4, using similar figures to solve these missing measures. So the figures below are similar with a scale factor of 2 to 3. Okay, so a scale factor of 2 to 3 will find the value. So pretty much what you want to do is you want to set up a proportion for this. So we have 42 and X. Those are corresponding angles or corresponding sides, just like what we had up here. So that's kind of like the JK and PM. They're on two different shapes. Well, then we know that 2/3 is our scale factor. So it's got to equal 2/3 when it gets simplified out. And the 2 will go up top because it's kind of obvious that the 42 is a little smaller than the X, and this X is the largest. So we'll put the 2 with the 42 and the X with the 3. So then after that, we just kind of cross multiply. That'll be 2X equals 126. And when you half it, that'll give you 63. So that's how you can find it. So 42 divided by 63 would simplify out to 2/3. So we can do the same thing with number 6, and now they gave us a similarity statement, which is really nice. So we know that AB, which is X, will correspond with DE. So X goes with 25. And we know that will be BC. That 28 goes up top. And BC corresponds with EF, which is 20. So from there, we have 20x equals 700. And we divide that by 20, and that will give us 35. You can do the same thing with 7. It's just using a congruency statement and setting up a proportion. So for number 8, exact same thing. Here we have AG, which is 32. AG matches up with KX, which is x plus 3. And then we have GM, which is 36. And that matches up with x plus 6, which is XD. So understand that these two are in the same triangle, right? Those are in the same triangle, and those are in the same triangle. You do not want to mismatch those. Okay, we're not crossing it as you're setting it up. We will cross multiply, but we're not going to cross it as we're setting it up. So that will be 36x plus 36 times 3 would be 90 and 18, 108. That'll be 32x, 180 and 12, 192, 4x and 88. And that will be, is it 88? No, it's 84. Hang on. Yep, 92 minus 8, yeah, 84. So that'll give me 21.